Any robot needs to be able to localize itself in order to be able to perform its duties reliably. In the case of a Roomba, you could vastly improve its ability to figure out where it is using a really cheap camera and our vision location algorithms. It would be able to say, oh, I know which room I'm in, I know which way to go now, instead of just kind of driving around until it bumps into a wall and trying to figure out which room it is based on how long it took to hit the wall.
What we're currently playing with is the ARDrone quadcopter, and it's basically a 4-rotor helicopter, so it's got 4 of these rotors, and it flies pretty nicely. It's got 2 cameras, one in the front and one in the bottom, and we're using these cameras to help it navigate and locate. So there are 2 methods that we're currently dealing with right now. One of them is to take a bunch of pictures ahead of time with the camera, and then we'll match the current images that the robot sees with the saved images and go, oh, well this one matches with that one, so clearly you're in the same place in the same orientation. And then the other half of the team is working on using these markers called April tags, where it uses the bottom camera to hover over it and recognize different tags as different locations, and these tags are very distinct and it can tell you what orientation they're in as well.
So some of the challenges we faced with trying to control the ARDrone was it has a consistent need to drift in various directions. And one of the ways that we fixed this was we simply told it whenever it's making corrections, just move faster or more in that direction so it kind of overpowers the drift.
So one of the tricky things with robots is if you want to check how well your algorithm works for its vision, if you just hold the robot or use the robot and run it again and use those algorithms to process those videos, you can't tell if you've improved or not because maybe the video is just different and the second video you took was worse or better or whatever. In order to take care of this, we stored videos from the robot onto the computer, and we just used the same videos over and over and over again to compare it against our algorithms and see how they actually improved. And you can even look at it frame by frame and everything.
Our research could benefit any robot that needs to figure out where it is, such as military robots, transportation robots, robots to assist the visually impaired, and search and rescue robots. These are just some of the many applications of vision-based localization.